Hello guys, and welcome to another multiple apps workflow tutorial with me, Eldrin from Logicil. Today we're going to be going over chapter 13 of our production pipeline series, and in this one I want to go over AOVs, drivers, motion blur, and depth of field in C4DtoA. Now that's a lot of topics, but they all have a lot in common because depth of field and motion blur are a part of the driver system, and they're passes that typically happen during a final render. So a lot of that kind of sort of falls in the same kind of sort of category. But what are AOVs? Well, in most professional renderers like V-Ray or I'm not sure about Octane. I haven't actually used Octane before, but it probably has a similar system. Maxwell, Arnold, all these guys have attribute output variables. And that's a little different than C4D's standard renderer because C4D's standard renderer has a multipass of sorts that you can enable that allows you to render out a bunch of different effects, as you can see here. But it's all kind of sort of built in, and you're limited basically to this list that Cinema 4D exposes to you. With Arnold, you can pretty much render out just about anything you can imagine. So any sort of property in the render engine that exposes itself as data pretty much can be rendered, which is why they're called attribute output variables versus multipasses. But they're kind of the same thing. So, you know, you can mathematically calculate something based like on a vertex point or something like that, and use it for compositing in your final render application, which is very useful when you have a powerful compositor like Nuke. After Effects can deal with variables like that as well, depending upon the plugins you use and different things. But particularly with Nuke, it's very powerful to have something like that where your color values can be used to hold something a little bit different than just color. Alright, so with that big hairy explanation out of the way, how do we create AOVs? Well, in Arnold, we don't actually necessarily use the Cinema 4D standard output system. So this kind of sort of save dialog kind of sort of goes out the window. Arnold supports a lot of formats that Cinema 4D doesn't. You know, Cinema 4D supports all of these formats, but with Arnold, you can actually render out most of those formats, and you can also render out deep EXR, which allows you to have pixel data that has multiple samples of pixel depth in it, allowing you to do some really, really cool things like composite a flat image into a fog render in your 3D scene. So enough talking about it, let's do it. In order to create a driver, you would just come over to your plugin and click on Arnold Driver there. Or go into your plugins and do Arnold Driver here. Now, once you have a driver, what the Arnold Driver does is it allows you to basically export files. So you can choose any of the drivers that are available in Arnold, and it supports all the most valid professional formats. TIFF, PNG, JPEGs, and of course deep EXR. So Arnold gives you the ability to render out deep EXRs out of Cinema 4D now. So you can get very, very, very amazing compositing capabilities at the cost of extremely large file sizes. The C4D display driver is a unique and interesting one. If you render with Kick, this is not going to actually do anything. However, here in Cinema 4D, it's going to allow you to come into the IPR here and actually see your different object buffer passes. And I rendered a scene previously here, so it's actually showing object buffer, or it's showing AOV passes from a previous scene that I had. But if we go into our Arnold driver and we go ahead and set up AOVs, we can see that we have a bunch of built-in AOVs as well as AOVs related to some of the third-party shaders that I have installed. So the built-in AOVs are pretty powerful. You've got your Z depth pass, which we'll be setting up in just a few moments when we talk about depth of field. You've got your motion vector pass, which is a pass that we'll be setting up when we do motion blur. The ID pass is an integer pass that can't be displayed in the C4D display driver, but it basically records a variable of a certain number for each separate object in your scene. So each object gets a different number internally assigned to it, and you're able to use that to drive compositing in your compositor. You've got volume passes now with the new version of Arnold that just recently came out, which is going to allow you to export Arnold or volumetric AOVs, which allows you to basically color your volumes in another compositing application. And you've got a few other ones that are useful in certain rare circumstances for doing different things. Obviously, you've got AOVs for each one of your different types of major shaders. So all the standard Arnold shaders apply, and then you've also got some passes that were created by the AL shaders and a couple of passes that were created by the oblique shaders. Alright, so to add an AOV, you just simply select it here and you just move it over to active AOVs, and it is added to your AOV list. So there we are. And since we're using the C4D display driver, these AOVs now pop up in here and we're able to see what they look like. The motion vector pass is not going to work in IPR. You can't see motion blur in IPR. The Z depth pass is a interesting one because it's actually it's a pass that doesn't actually store the color value from white to black like in a typical renderer that you would expect. It actually stores an integer value of the depth from the camera and out to the end of the scene. So it's actually a numeric value rather than a kind of sort of color value. So it always appears white in your render here, and it also would appear white in After Effects. But once you do some calculations in After Effects or Nuke to kind of sort of convert that value into a kind of sort of gray to white map, it works perfectly for your depth of field. Also, if you're using it with something like FreshLift depth of field, that will just read the pass just fine without any conversion at all. So FreshLift understands the numeric calculations that Arnold does. And Nuke, you have to do just a tiny little bit of work to get that pass to work. I believe you just it's a little drop down in your depth of field node. Off the top of my head, I can't remember exactly which node that is, but if you just change it to a different calculation, it basically recognizes that map and it calculates it out. So Arnold depth of field is slightly different than what you're used to. The motion vector pass, you could use vector blur in Nuke to handle that, and in After Effects you could use something like real smart motion blur vectors. Alright, so let's say we want to write a custom AOV. Let's say we want to edit Testa and Forest Walker separate of each other, maybe change their color in post, give ourselves a little bit of capability of maybe enhancing this, giving these better contrast, different things like that. So there's a couple of ways to do it. There's the really quick way that as a beta team we kind of got Arnold to kind of sort of implement for us, and then there's the slower but more effective because it gives you a little bit more control kind of sort of way. So let's go with the slow way to start with. So here we have a material for our text, and this material is applied to both these objects, so we can create a AOV pass for this material that basically would affect both of these objects together, and we won't be able to really separate them unless we create two materials. But if we open up our network editor, we have a setup here where we have some displacement and we have some bump and different things, and we want to add an AOV to this. So in the Arnold shaders here, we have an AOV drop down here, and includes all of our AOV passes by default with Arnold. And so we can export out any variable that we want related to any of the objects that we have in here. So if we want to export out, numeric values for some sort of noise that's defining some sort of unique object that we maybe want to add to our objects and add to our polygons in Nuke or something like that. We could write out some integers or some floats. We could also just directly write out a RGB, and this is going to write out a color for this shader network. So what we want to do is we want to actually plug the AOV itself directly into the beauty port, and we want to plug in the shader output into our pass-through. And so what's going to happen is this is just going to pass right straight through this whole shader network right into the beauty pass, or the beauty AOV basically. And so that just gives us the same look as we had before. What's really cool about this technique though is now we can use any of the shaders that we have here. A math shader, we could use conversion shader, light filters, anything at our disposal to create a custom AOV. So, maybe we don't want to color, this whole object. Perhaps we want an AOV that will only allow us to add some sort of color or some sort of contrast just to specific areas of the object, maybe a cloudy kind of sort of area. So we could use something like AL flow noise, which we could plug into our beauty port to kind of sort of see what that flow noise is doing. So, now that we can see it, we can come in and we can affect perhaps the gain of it, make it brighter. We could affect the frequency of it, create more of it. We could change the mode so that we get, a different look, something like that. And then in After Effects we could use this as a black and white pass that would only allow us to affect certain parts, so we get like a really cool effect out of this. And so what we can do is we can go ahead and plug that flow noise into the AOV input, and so now this noise is basically going to act as the AOV, and we can go ahead and plug the AOV back into the beauty pass, and everything's back to normal as it was before. The only difference now, of course, is that, and I'm just going to organize these, kind of OCD, and the only difference now is that now we have an AOV that we can plug into our drivers, and that will export out with our scene when we go into Picture Viewer and render this out. So we can name this AOV whatever we want. We can call this text pass, perhaps, and that will basically do it. So now we have a AOV that is a text pass that we can use in After Effects or Nuke. Now, all we need to do is just add it to our driver list here. So we can do that one of two ways. We can come in and we can add an Arnold AOV directly, which we can add to our driver, and we can go ahead and actually name this and call it text pass. And if we go into our setup AOVs just to kind of sort of double check our work a little bit, we can see that under our active AOVs we actually have the text pass, and so that will render out with our scene just fine. Vice versa, we can come in here into setup AOVs and we can go ahead and add a custom AOV, and we can call it text pass, and we can set up the data type, whatever it is. It's going to be based on our shader network. So if we set up a AOV integer, then we're going to want to select integer here, and we click OK, and same thing happens. We get a text pass as our active, and we get a text pass here. So it just depends on which way you want to work. It could be easier to create an object and drag it as a child, or it could be easier to go into the Arnold drivers themselves and set up the AOVs there. Whichever way you want to think. Everybody thinks differently. But But in order to render this out to an actual real image, we probably will want to go ahead and switch this to a different driver. So switching this to EXR is going to allow us to write out an EXR. And once we have that set up, all we need to do is come into our file path now and go ahead and select a place to render this out to. So we're going to come over here to test 2, and we're going to come over here to the forest walker scene. We've got a pre-rendered scene here. I'm going to go ahead and create a comp. I guess I'll call it final here, and we'll come in there and we call this forest walker underscore. And that's just so that, you know, when we have that little 000 whatever here, we have a nice little underscore to break that up. All right. And then in our file path, if we want to render this out of the sequence, we want to make sure that we have those hash marks so that Arnold knows that we want this to be replaced with a sequence of numbers. And then let's just add our extension at the end of that. And that is it for us. Coming down here into our attributes here, we're probably going to want to, actually it's not here, it's right here under driver. We're going to go ahead and merge the AOVs, and that's going to create a single EXR file that has all of our passes in one file. Vice versa, if you like to deal with multiple different passes and multiple different EXR files and just kind of sort of work with those together, which can be useful in something like Nuke. You might want to have your different passes kind of separated into multiple nodes instead of just dealing with one node. I personally like one node myself, but if you like 8, 9, 10 nodes with, you know, multiple passes, then certainly uncheck this and that'll work just fine. And that will pretty much do it. The tiled effect is kind of useful. This allows you to do some interesting things with Kick, and it also makes it a little bit easier for things to load in Nuke as well. It basically breaks up your file into, internally, technically, it breaks it up into multiple different cubes, and basically allows it to be loaded compartmentally, which makes things a little bit faster. It's kind of similar to the same way that TX works, and it's the reason why Arnold is able to render out texture so fast. Alright, so that takes care of those passes. So that's pretty much it. Now, let's get into the depth of field and the motion blur. So for depth of field, it works quite similar to Cinema 4D a little bit, with some slight differences. First of all, you're going to need to create a camera, and we call this the shot camera. And we can go ahead and lock this camera down so that we can't move it. Alright, and we're going to want to put a Arnold parameters tag on this camera. And then we'll just enable depth of field. Alright, now depth of field will render in the IPR. And so if we want depth of field from Arnold, it's a pretty simple thing to do. Let's just check our render settings here. Yeah, there's no depth of field that we have to turn on here. So yeah, we just come in here and we just change the aperture size just a little bit. And when you change the aperture size, you start to get depth of field. And that's pretty much it for depth of field. It's pretty simple. The aperture blades controls how many blades are in your lens itself. When a camera takes a picture, there's a shutter that closes like a kind of sort of eye of sorts, and it has a certain number of metal blades that it uses to close. And depending upon the number of metal blades that are there around the circumference of that circle, you get different looks to your actual depth of field. So you can control the blades, you control how curved the blades are, how they rotate, all that kind of good stuff. You can also control whether or not the aperture is an actual, you know, true circle, or whether it's more like a fisheye of some sort. But in order for us to focus this depth of field in any particular location, we need a focus object. So we can go ahead and create a null, and I like to call it my cam focus. And I like to usually just put it like near my camera so I can find it in the object manager really easily. Under the shot cam, we can go ahead and put the focus right there in the focus object, and then we can just simply move our focus around. A good idea would probably be to change this into a sphere, give it some radius a little bit, have it face any other axis other than camera, and now you can kind of sort of see it in the scene. You can move it around and you can get an idea of your depth of field. So we could put it like right here in the center, or maybe put it on the S, and that's going to be our depth of field area. All right, go ahead back into our camera, and now we've got depth of field exactly where we want it. The text is clear and the background is faded out. And Arnold depth of field renders out pretty fast. You're going to have to be a little bit careful with it though. Depth of field, in order to clear out the noise that comes from depth of field, the only way to do it is to mess with the AAs, which means it increases the value, the render value exponentially of everything. So if you really have a tough scene with some really tough depth of field, you need to bring the AAs up to like something like 10. You might want to compensate for the drastic increase in all the other values of your samples by dropping them all down to 1. And that will take care of your depth of field, and it will also allow you to not have drastically increased render times because these values are set a little bit higher. But we don't have any SS in the scene, so I'm going to go ahead and turn that off. And so that's pretty much depth of field. Motion blur works exactly the same way. We can go ahead and enable it here. Although depth of field does not have to be enabled in the Arnold render settings, the motion blur does have to be enabled here. And it also can only be denoised by actually increasing the AAs. So if you have to have motion blur out of Arnold, then make sure that you decrease your other sampling methods to compensate for that. But all right, usually because it takes a little bit of a while, even though it's extremely fast, it does take a little bit of a while in certain complex scenes to go ahead and calculate out depth of field. So oftentimes you'll want to composite this effect. And so depth of field is an AOV. It's the Z depth pass. In order to generate a accurate Z depth pass, you just need to have a camera focus in your scene. You need to make sure that your camera has depth of field enabled right here, and you could set your aperture size down to 0, and basically Arnold will render out a depth of field pass using the aforementioned methods that I mentioned at the beginning of the tutorial. And then you can use something like fresh lift depth of field in After Effects or the Z defocus node, I believe it is, in Nuke, to go ahead and tweak that to your leisure. Alright, so for the motion vector pass, in order to generate a motion vector pass, you need to set the shutter to a instantaneous shutter. So the way motion blur works in the real world is the shutter starts to come down in your camera, and well, it opens and it starts to absorb light onto the chip, quite similar to how your eyes work a little bit. And as it absorbs this light, if an object is moving, it's absorbing light of that object at different intervals of time. And once the shutter finally closes and finishes exposing that image, you get a blurred out object. Now, if the shutter were somehow in the real world able to close almost instantaneously. Like if you had a shutter speed of like 1/4000 or something like that, then you would get a crystal clear image of whatever object you were capturing. So the motion vector pass needs that crystal clear version of the object in order to be able to calculate out its magic. So looking here in our render settings, we can see that our length is 0.5 and its center on frame, shutter angle is 180. So this length is kind of the value that we want to use here for our shutter start and shutter end to give us an instantaneous shutter. So we'll just go ahead and set both of these to 0.5. And that means that the shutter is going to instantaneously open and close on the scene. And we have motion blur enabled here, and that's all we need. And that's our motion vector pass AOV. We can take that into After Effects and we can do some passes on that. Alright, now if we want to see all these AOVs in action, then what we can do is we can come into our render settings and we can go ahead, and this will be used in Arnold to go ahead and render out our image. And let's set our frame time to 24, hit Control D, make sure our project is set to 24 as well. And so if we render out the current frame to the picture viewer, it's going to go ahead and render out, and we'll be able to actually see this on our hard drive. So if we come over here to Arnold here, and we come over to the Forest Walker scene, come over to pre-renders, come over here to final, you can see now that it's rendering out, and it's got those hash marks. We had 3 hash marks, so it's rendering out a 3-digit sequence here. It's rendering out the current frame, which was frame 18. And it's going to go ahead and do that for us. So I will meet you guys back on the other side. And so here we are in After Effects looking at the final render. And if we go ahead and go to our Effects and Presets panel here and use the extractor, drag that onto our EXR, we can go ahead and utilize the motion vector pass here, R and G and B, click OK, and the alpha should be that. And yeah, we have no motion vector pass, and that's because there's actually no movement in our scene. So that's actually pretty hilarious. I'm going to have to animate the scene a little bit for us to see that. The Z depth pass is purely white. But if we go into 32-bit mode, we may be able to see better values for this, because this is a 32-bit image. So let's click on our 8 bits per channel, change that to 32-bit. And so yeah, now we're seeing these really large values. So if you look closely here at the RGBs as I mouse over the object, you can see that we're getting these extremely high numbers related to different depths in our scene. And so once again, Arnold calculates depth based on where the camera is and all the way out. And so something like FreshLift will be able to read that just fine. So we go ahead and do an FL and hunt through here. We can go to FL depth of field, and we can place that on our object, and we could use this Z depth pass as our depth layer. We can call this Z. We can go ahead and actually Control D, duplicate that, call this the original, and take off the extractor for that. And then we can use the Z as our depth layer, and then we can start to increase the radius, and we'll get some nice depth of field out of that. Select our depth here, and there we go. And then probably just want to play with a few parameters to go ahead and get this to smooth out a little bit, because we're getting a few black pixels here. But other than that, that's kind of how that goes. Real smart motion blurs. Vector pass is similar. For the motion vectors, you would use the motion vector pass, and then you would just go ahead and start to blur that to your liking. All right. Let's see, what else do we have in here? We've also got our text pass. So we can go ahead and grab the R, G, and B for that. We can also grab the alpha. And what's really great about Arnold that I really like a lot is that Arnold will actually give you a alpha of that pass, as well as the pass itself. So that's really amazing. So just in case you don't really know the power of that and what that'll do for you, is because it gives you an alpha, you can actually either use a Luma mat to actually composite this, or and let's go into our track mats, and we could either use an alpha mat and we can actually get the text by itself with no background at all, which is really powerful, or we can go ahead and actually just use a Luma mat and get something like that as well. This is a really great way to also create like a really awesome effect. If we were to animate the flow noise, we could get some really, really cool looks out of that. Alright, but that brings us back to Cinema 4D. And there is one more technique that you can use to get an AOV for the text. And that would be a really good technique for this scene. And it'll also allow us to get a really nice AOV for the jewels as well. And it's very simple. It's the same technique you would normally use in Cinema 4D. Normally you would use a compositing tag with an object buffer. C4DtoA has its own little compositing kind of sort of tag. It's called the object mask. So you just add an object mask. You set up what you want the name to be. So text to text mask. And that's it. You're basically done. Let's go ahead and copy that over to here, and we'll call this forest text mask. And then we'll come over here to the cloner, and what this is going to do is it's actually going to look at everything underneath. And it's going to go ahead and set an AOV for all however many of these objects. I think 3 times 3 times 3, so it's about 9, about 27 give or take jewels. So it's going to set up an AOV for all of those. And we can call this a jewel mask. And then in our drivers, all we need to do is just go over to our driver tab, go to setup AOVs, go to custom, and we can just add all these AOVs to our active. And so that's really, really, really simple. So you've got the for some people, somewhat more complicated method, a little bit of doing the pass-through. And this is really powerful because you can pretty much use any shader you want to create a matte for your objects. And as I showed you in After Effects, that could be really, 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 really powerful. Vice versa, you can always use the easy Cinema 4D object mask type technique and just quickly get black and white mattes for your different objects. So if we go ahead and render this again, and I will meet you guys back on the other side. Here we are back in After Effects, and I've cleaned the Z depth pass a little bit. There was a FL effect attached to the Z depth, which was throwing it off and causing those little black spots. So now there's just only the extractor effect on there. But if we go ahead and duplicate this layer, and we can call it test mask, and go ahead and look through it. Now we have our mask from the from those object masks that we created in After Effects. So got the test mask here, and we can go ahead and use it for all of our values here. And so now we have just a nice fully white pass for that. So we can go ahead and duplicate this, call this test to text, perhaps. Bring that up, and we can use this mask as either a Luma or as a alpha. Like I said, I really love the fact that Arnold gives us those alphas. We get very, very clean track mats out of that. So just use an alpha mat, and basically our image looks exactly the same as it did before. Only difference being now, we can come in and we can use something like a curves to only affect just the text. So now we can brighten that text, make it punch a little bit more, add some more contrast to it. You know, we can go ahead and add maybe a hue and saturation, change its coloration up. Maybe we want to colorize it and change what the hue is, because we don't like that green. Maybe we want to go for more of a red, perhaps, or purple. You know, saturate that out a little bit more, you know. And so we have all that power available to us. You know, we could duplicate both of these as well, and you know, these are going to be the forest text, perhaps. And this is still going to be the forest mask. So we can come in with these two and you know, change up our hue this time and use different hue. Obviously we want to come up to the mask, and we want to go ahead and change which mask we're using. So and so now, there we go. And, you know, so that's pretty awesome. Alrighty, so this one's getting slightly long in the tooth, but I'm sure that's a lot of information for you guys to chew on. And you'll be able to render out some really awesome AOVs now and really get into your compositing. In the next tutorial, I'd like to actually cover up some more details on AS files themselves. Particularly how to render out with Kick. So you don't actually have to render out these scenes in Cinema 4D at all. You can actually export everything out, the whole entire sequence out as a Arnold scene source export, and then you can actually render all those off using a completely different version of, or a completely different plugin of Arnold. You could use Maya's Arnold to go ahead and render that scene, or use Houdini's Arnold to go ahead and render that scene. Or on a render farm, maybe you just have just a Linux render farm. So you could ask Solid Angle to give you the C4D shaders for Linux, and you could actually just render on 50 Linux machines and not even have an installation of C4D at all. So I'll show you how to do all of that in the next tutorial. See you guys then.